When we are looking at sketching a slope field here, in question 1, we are given the slope is equal to x minus 1, okay? So that is dependent on what x value you are plugging in, right? So if your x is 1, what is your slope? 0. So on this graph, where is x equal to 1?
2.
X is equal to 1 like here. Yes? Those are all places that would have an x value of 1. Am I right?
Okay.
All right. So all of those places have a slope of what? 0. So that means I draw these nice little slashes in here that show a slope of 0. So anywhere that x is equal to 1, I put in these nice little short dashes that have a slope of 0. All right, so then let's look at another place because we did all the x's where they're equal to 1. What if we were right here in this section? Okay, your slope would be 1. What's a slope of 1 look like? Yep, you do a little diagonal. And it just has to be something that could be a slope of 1. It doesn't have to be like you're really counting rise over run. You just want to be somewhat accurate with a slope of 1. I'm just drawing little dashed lines. Mine might be a little bit less, but here's the important thing. Compared to the first set we drew, that is a larger positive slope. Yes? As long as you show that, that is enough. Okay? So then if I kept going, the next line to the right, what would your slope then be? More positive. It'd be 2 for all of them, right? So again, as far as this goes, you really just need to make sure your little slashes are steeper.
How do we know? I think I'm lost. How do we know that
All right, so are we good on the right side there? All right, so let's continue to the left then. In this entire column right here, what is my x value going to be?
-1.
So my x value there is 0,
Oh,
which
sorry.
means when I plug that in, my slope is -1,
So you
right?
just go the other side.
And if you start getting those patterns, you don't really have to think as hard about each section. Now we know here our slope is about -1. And what's going to happen then the more I go to the left? Yeah, it's just going to keep going steeper and steeper, but this time negative, right?
How do you distinguish though? Like, I feel like it's kind of gonna be.
It is a little bit. It is a little bit weird that way, but if you just keep trying to show it getting steeper as you go, so don't increase too much on each one. But usually when I get super steep for these, like the last one, mine will be almost vertical.
Oh, you do.
I don't quite do vertical, but I try to show that it's getting more and more.
is this like enough to?
But the next one, this time my dy dx, my slope is 2x. The first thing I tend to ask myself is like, where is it 0 then? Because that helps me just give myself a starting point. So that slope is going to be 0 when my x is what? 0. So then I know at 0, the whole way down for x, I have a slope of 0. Okay, so then if my x is 1 next to it, what's my slope going to be? 2. So it's going to get more steep faster on this one, right? So I have a slope of 2 here. What's going to happen as I continue to the right? Steeper and steeper. So as much as you can, show steeper and steeper. Okay, so I'm going to show a little bit more steep after that. And get almost vertical on the last one.
And then the same on the other side.
Yep, but at this time that slope will be what? Negative. And like if you compared this one to the one next to it, they are different because you're showing it gets steeper faster.
I feel like it's hard for me to do this.
Well, you guys like an exact, like this for some of us is not going to be something that feels great because it's not an exact science. And we don't like that. Now, this lends itself very much to multiple choice. It would be very, very easy for them to give you a picture of one of these and say which equation matches this. Okay? Okay? As far as like a free response question, this would be one small part out of that.
I like this. I just
Yeah.
feel like I like.
Yeah.
it's not
Oh, yeah.
something
Right now,
that-
you just feel like you have to be too intense about it. All right, what's different in 3?
Why?
It's the y. So where's your slope going to equal 0 this time?
Why?
Where the y is 0. So sometimes you have to flip how you're thinking about this. Now we're not going to go with x's. Now we're going to go with the y's.
To go horizontal.
Okay? Yep, we're going to go horizontally. So where our y is 0, which is all along here, I'm going to have a slope of 0. Now I have to draw that like slightly above that because I can't show it otherwise. When y is 1, which is now this entire row,
Slope is 2.
my slope is 2. All right, so this one has a slope of 2. That might not be steep enough. There we go, the whole way across this time. What's going to happen as we continue up?
Steeper.
Steeper. What's going to happen as my y's go down? Negative. The first one will be -2. The second one will be -4. So I will just try to show a slope that appears to be close to -2 here. And I very much do these the way I'm showing you right now, like either in columns or rows or in sets of something. You're going to see it's not always going to be columns of x's and rows of y's. Sometimes it's going to be like patterns of points, which we're about to see here. Okay? All right. Continuing. If you have a question, just yell. Here's where we start to see, these notes tend to be long and a little bit like, whoa. So I'm trying to like get through some of these without being too nitpicky about them. This is where we're going to start to see patterns, because now this is subtraction, okay? Subtraction or division and stuff like that, okay? So instead of being able to say there's a whole column of x's where it's 0, I can't really say that anymore, can I? So how am I going to know when this slope is going to equal 0?
The same number.
When x and y are the same numbers. All right, so where is that going to be? Well, that's going to be right here when the point is 1, 1. Or right here when the point is 2, 2. Or here where it's 0, 0. So this entire diagonal now is going to be flat slopes of 0. See what I mean about sometimes there's going to be patterns? It's less of an entire column here and more that row or diagonal, excuse me, will be 0. Then I have to kind of reason out the other parts of this for myself. So like,
Y is greater than
right,
X.
that's exactly how you're going to think. So over here, like this is the point 2, 0. Okay, so all in this diagonal, it's going to be positive, but it's not necessarily going to be the same number. So I have to go through, I try to find myself patterns here. So if this is, 1, 0, the slope will be 1. This is the point 2, 1, the slope will be 1. This is the point 3, 2, the slope will be 1. This is the point 0, -1, the slope will be 1. So this diagonal that I've just circled, that's all going to have a slope of 1.
Can I assume the one above it will be all negative? Or
Yes, -1. So I've got a slope of 1 going here. The diagonal above it, the y will be bigger than the x, so my slope here will be -1.
And then the one below the positive.
Mhm.
You're saying it's similar?
It's going to be more steep.
Yeah.
Yep. So like all in here, the x's are going to be 2 bigger than the y's. Therefore, the slope is 2. So some of them are not like crazy fast because you have to reason out those patterns there. And then the one above the one will be -2. So I kind of continued out that way doing my patterns. Now, at a certain point, once you discover those patterns, oops, that's not the diagonal, lies. Once you discover those patterns, you can kind of go quicker and just say Once I know that pattern, each of these diagonals is going to get steeper and steeper until it's pretty much like vertical up there.
Looks so straight.
It does. And then the other ones are going to become more positive as we go until they become almost vertical there. Some of them will be helpful for you to identify how the XY points work in quadrants. And that is like the division type. I really feel like the next one is kind of that way. And what I mean by that is, in first quadrant, the X is positive and the Y is positive. In the second quadrant, the X is negative and the Y is positive. In the third quadrant, they're both negative. In the fourth quadrant, X is positive, Y is negative. When you're dividing to do a slope, it can be really helpful for you to reason that out. It won't tell you the exact number, but it will tell you where they're all like positives and negatives. Again, though, I do start with the zeros as much as possible. So if my slope equation on 5 is negative x over y, where is that slope going to be 0, excuse me? When x is 0, right? When x is 0, but y is not 0, right? Because 0 over 0 is what? Undefined. So when x is 0, those 4 places, I have a slope of 0. Why do I not have a slope of 0 right in the middle? Because y is 0. When y is 0, that is undefined. So if they're both 0, you really can't get an answer to that. But if x is a number and y is 0, it's undefined. What's undefined as a slope look like? A vertical line. So all of those places, we have vertical lines because y is 0. Now in the middle, I have nothing because 0 over 0 is not something I can even draw. Okay? So then as I go through the quadrants then.
If it's a negative over a negative, if it's negative out front.
Right, so there's a positive over a positive would usually be a positive, but there's a negative out front, which means it's negative. So then I know when my x's and y's are the same, it's going to be -1 in the first quadrant, right? So if I can go up this diagonal knowing that my x's and y's are the same, therefore it's -1. Okay. We can't because then on the other way, a negative over a negative is a positive. But then if it's negative, it makes it, so you can continue this way then? Because a negative over a negative with a negative in front makes it negative again. Then the other two, the other ways, are both negative, but with the negative out front, it makes it positive. So this way is going to be +1 slopes.
Do you have to fill in all the extra stuff?
So you can kind of see what's happening here. Do you kind of recognize what shape this is going to kind of make?
Or a circle.
It's really going to make like a circle of slopes, right? Concentric circles. Yep.
Rings in a tree trunk.
Okay. So I do kind of want to reason out where it's more positive and less positive. So like over here, my x is going to be bigger than my y. So what are my slopes going to become as I go out to the right? Bigger, because the x is on top. So a larger x on top makes that more of a slope. This one up here, the y is bigger than the x, which means it gets smaller, flatter.
Oh wait, and that one they're the same, so it'd be 1.
Yes. This one's the same as that one. And then you can kind of reason out the rest of them as you go. It kind of follows that same pattern where this one is a little bit flatter. Then out here they become more negative. Same idea here. This is flatter, more steep this way. Now, you can plug in points as much as you need to do this. Because you do have, like, these little dots are XY points. So if you are not sure, plug in the X and the Y from that point. And that will work every time.
Are we going through all of these points?
No, probably not. I'll leave some of it as practice for you guys to do. Because eventually, we'll get enough of each type. Like this feels like enough of the different types of graphing them, okay? So then next step, we're gonna hit matching slope fields with differential equations. So this is a matching section, okay? So just a couple tips as you look for how to match graphs. This is, again, very common in multiple choice stuff. First, we're gonna look for horizontal or vertical patterns. And that should make sense to you because that's just how we graphed them ourselves, right? So I look for like, okay, so where is it 0? Okay, so if it's vertical, that's all the same x, okay? Or if it's horizontal, that's all the same y. You can look for where the slope equals 0. That was the first thing we did when we were graphing them. And we said, where does the slope equal 0? Let's draw that in first and then reason that around. And then you can look at whether certain sections of the graph have positive or negative slopes. This will often happen in quadrants. And that's kind of like that last one we just did. We looked at where it was positive and negative in quadrants to help us. Okay? So then if we're reasoning through this, okay, so let's take it one at a time. Top left graph. Where do I have a pattern and a slope of 0 in that one? Top left graph? Oh, okay. I'm not looking at the equations. I'm going to look at the graphs first. Okay? So like this graph right here.
-1.
That one has one at -1, and that's where the x's are -1, right?
So that could be F.
So which one could that be? F. Yep. There you go. Yeah. If you can pick those patterns, it is easy. Let's look at the next one. Where do I have that 0 pattern again?
3.
Yeah, right here at 3.
X equals 3, so A.
So that will be A.
This is my thing.
Mm-hmm.
I like it.
All right, let us. Okay, so then like the next one doesn't have a 0 pattern.
But at Y.
Okay,
Oh, wait, no,
maybe
that's not
it's
right.
vertical at Y. Let's come back to that one. I'm going to pick out, like, when I go through these, I pick out the easy ones first. So, like, let's go down to this bottom one. Where does this one have a 0 pattern?
1 at Y.
-1 for Y, right?
So E.
So which one's that? E. All right, what about the middle one? 3 for Y, which is B. Okay. All right, and then the last two. So we have eliminated A, B, E, and F.
At 0.
Okay, so at 0, I do have a flat line there.
So that's
Okay, so which one is that?
D.
Okay, so that's 0 for Y, so that must be D. Okay,
So then whatever.
what about,
So C.
okay, C? Yeah, this one looks funny. It doesn't have a 0 at X. Why is that? It seems like that has to be right. Why? Sure, yeah. Yeah, it has to be, but I don't like the one in the middle.
Why is that one D?
This one, because with the middle line being 0 there, that's where your Y is 0. So Y squared is 0 for that one. Okay.
But 0 and 0 is undefined.
Right. So they did some in the middle there, so I'd be careful with that. But yeah, that one's all dependent on the Y's and not the X's, which is why it's okay with that, because it's not a division problem.
Oh,
Okay.
I like this.
So the matching part, not so bad. Yeah. So then on your own, why don't you guys just go ahead and play matching on ABC right here. Okay. So those are all vertical, which means that's undefined when X equals 0. So because of those being undefined, so those are all undefined at X equals 0. And then these are all 0 at Y equals 0, which makes sense with the equation I have for A. Okay?
Will we ever have to show reasoning?
No, you just need to be able to do it. Yep. So there's that. Now, the last thing we have to talk about is matching a slope field with a solution curve. Okay? So first off, slope field gives you the slopes, which is the derivative. Okay? Solution curve is the original equation. Like if you integrated. You know, this is why it goes together with this, because we've been integrating differential equations to find the original equation, right? So they are not giving you, in the answers here, these are not going to match the way we just matched in the last section with the slopes, because these are not the slopes. This is the original equation. So this is the integrated version, okay? Now, the long way about doing this, which I do occasionally when I'm not feeling confident. I will just tell you this because it's my backup method. The long way is to do the derivative of each one and see which one matches with the slope field. That is not the best way. The easiest and best way is to draw in on the slope field a curve based off of the slopes. Okay, and so essentially what I can do here, and it's not going to be an exact one, but it's going to be enough for you to see a parent function idea here, based off of the slopes that they've given me here.
It looks like at one.
It's almost like I have an equation doing something like this in there. Exactly. So although that it might not be positioned right there, I can't draw anything in here that's not making that curve, whether it's up or down or a little bit to the side, okay? The slopes tell me where to change my curve to kind of line it up. It's not an exact science, and I totally get that, but it's enough for you to know. Does that look like an x squared?
No.
No. Does that look like an e to the x? No. What does an e to the negative x do? Reflects it over... Yeah, so we know x squared looks like this. We know e to the x looks like this. We know e to the negative x looks like that. Cosine x is that.
Yeah.
Ln x is this one. Which one does it look the most like?
Oh, okay. So
E.
it just looks intimidating.
It looks intimidating. Okay.
This is a stupid question, but why does y equals e to the negative x switch over the y?
So when the negative is on the x, it reflects over that. When the negative is in the front, it reflects over the x. Okay? All right. We're just going to do a couple more of these and we will be done. Okay? So let's look at question 2 here. All right. So this one asks about solutions again. So this is where we're going to practice maybe drawing in what the solution could look like. Okay, the issue with this one is that depending on where I start my solution curve, it's going to look different, right? If I start my solution curve like up here somewhere, in here, my only option is for it to go up, right? I could start my solution curve anywhere in here and it's going to go up. What happens if I start it below? It's going to go down, okay? Has to go down. Now, again, these aren't exactly perfect, but it has to be like that, okay? So these are all possibilities. So let's look at our choices, because these are great multiple choice questions where it's 1 only, 2 only, 3 only, you know, all those. For x is less than 0, all solutions are decreasing.
False.
X is less than 0. Okay, so yeah, false, because that's your x. Y being less than 0, sure, not x.
So anything.
All solutions level off near the x-axis.
I know A and
Yeah, all of these are going to level off here. You can't go past those because it flattens out, right? So this is true. For y is greater than 0, all solutions are increasing. True, false?
True.
True. Therefore,
Yay.
2 and 3 only. Okay. So just being able to draw in possibilities and level off, do stuff like that. That's all we're really doing. Okay? All right. I would like to do, I don't know. Let's say, let's just look at like this last one. If I started above the x-axis, it looked one way. If I started below the x-axis, it looked another one. One more and I'll be done. All right. So just a little bit more practice on this here before we go. All right, so we have a slope field for that. if y equals g of x is the solution with the initial condition, -2, -1. When they give you an initial condition, this doesn't mean you actually need to like separate the variables and do integration and do all of that. It means that your solution curve is going to start at that point. So I can draw in basically the point -2, -1 right here. Okay, now that's an estimate. I get that. But when they give you a starting point for this, remember on the last one I told you depending on where you started, it would look different? That's why they'll give you an initial condition like this, because when you start there, then it like restricts where you're at. So like from that point, if I continued this way, what does my curve have to do in here? It has to go this way, and what's it going to do at the axis? Level off. Once it's 0 there, I can't pass that. Okay, none of the slopes are telling me to be able to go past that. What about going the other way? What do I do with that?
They level off the other one.
Yeah, they level off the other way, so it's like I've got this going on here. Okay, so that's the only type of curve I could draw there. Now let's answer this question. What is the limit as g of x approaches infinity? Which way am I following that? To the right. What is that leveling off at? 0. Oh, look, combining limits with slope fields.
Limits are like the limit.
Yeah, they keep coming back, don't they? All right, see if you can reason out question 2. This is a slope field. This is matching the way we were matching before. This is the slope, therefore I'm matching the slopes, not a solution curve. I don't have anything about the slope or the solution curve. Okay.
Looking at what's like a special thing about.
Yes. So my first question is always, where is it going to be 0? And if I realize that this is only going to be 0 at the point 0, 0, well, there's a lot of places here that this one equals 0, so no. There's a lot of places here that this one equals 0, so no. A lot of places here where it equals 0, so no. So it must be B. All right, I'm going to skip a couple of the next questions and go over to 6. We didn't do that much with the solution curves, so I just want to hit like 2 more questions on that. Then I'll be done. Okay? All right. What I would like you to try to do is draw into question 6 what a solution curve could look like. First off, okay? So if I look at this, okay, and this had the initial condition, I didn't even put this in there, but this had the condition y of 0 equals 1. So I didn't even do that in mine, but I'll back mine up a second. Let's say if I did have that initial condition here, it puts that, it has to be there, which means I kind of draw it going this way, and I draw it going that way, yeah? All right, so let's play elimination here. Okay, which ones do we know that it's not right now? E to the x. We know that does not look like that. What else?
Well, at 0.
What does 1 minus x squared look like? That's a quadratic. That is negative. Okay, it would look like that. Is that a possibility? No. All right. What else do we know it's not?
Well, it can't be D either, right?
Why D?
Because it's.
What does a root not have?
It's like
A negative side. Nothing. All right, so we're down to this one. These 2. Does the cosine at 0 equal 1? Sure, so we have that. If I plug in 0 here, do I also get out 1? Yes, okay, so we check our initial conditions. The issue with the cosine is this. Watch your x-axis here, okay? The cosine is going to hit what? And then it's going to go where? Negatives, okay? With these slopes down here, it's forcing you to level off before you even hit 0. So can it be, this right there is indicating that we have a horizontal asymptote at y equals 0. If there's a horizontal asymptote at y equals 0, can it be cosine? Nope.
Oh, but for like something.
But for the rational functions, we do have horizontal asymptotes. Okay? So the flat stuff like that is indicating your slope leveling off at 0 means it's a horizontal asymptote there.
Can a sine or a cosine ever have a horizontal asymptote?
Nope.
Probably a stupid question.
Only
Nope.
tangent? Oh.
Tangents have verticals. Okay?
Oh, that's bringing back that.
There. Parent functions, we just did that this week.